You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we focus on the 4 core operations that every computing system performs. These operations, input, output, processing, and storage, define how computers function at every level. You'll learn how to recognize each of these actions in real-world systems, understand their purpose within a device, and see how they relate to the exam. We'll break each term down into simple, approachable definitions and connect them to the kinds of devices and software you use every day. These building blocks form the conceptual structure of computing. Understanding these 4 functions is essential for passing the ITF Plus exam. They appear in multiple domains, from infrastructure and hardware to troubleshooting and security. They are tested through both straightforward and scenario-based questions. For example, you may be asked to classify a device or explain the sequence of events that occurs during a basic task. Once you grasp input, output, processing, and storage, often referred to as IPOS, you gain the ability to understand how systems behave and how to analyze their performance. Input is the act of sending data into a system. Any method used to communicate information from the user or environment into the computer counts as input. This includes typing on a keyboard, clicking a mouse, speaking into a microphone, or tapping a touchscreen. Input may also come from automated sources like sensors or scanners. If something is being submitted or entered into a device, it is likely an input function. This is where interaction begins, and without it, no computing can take place. Examples of input devices are everywhere. Your smartphone's touchscreen collects input through taps, swipes, and gestures. A fitness tracker takes input from your body via motion sensors. Thermostats collect temperature readings as input data. Webcams send visual data into the system, and biometric readers like fingerprint sensors transmit physical identity information. All of these devices convert external activity into digital signals that the computer can understand and act on. Processing is the core function that transforms input into meaningful output. It involves interpreting the input data, applying logic or calculations, and determining what should happen next. Processing is carried out by the Central Processing Unit, or CPU, which performs operations based on instructions. It can range from simple arithmetic to complex decision-making, but its role is always the same: convert raw input into usable actions or results. Processing is invisible to users, but it is the heart of every system. Inside the computer, processing follows a repeatable cycle. The CPU fetches an instruction from memory, decodes it to determine the action, and executes that action. This cycle happens billions of times per second. Processing is supported by other components, such as system memory, chipsets, and internal buses. Each piece helps move instructions and data through the system, enabling the smooth execution of programs and operations. The speed and efficiency of this cycle determine the system's overall performance. Output is the process of delivering the results of processing to the user or another system. If input brings data into the system, output sends data back out. Output can take many forms: visual, audio, printed, or even physical movement. Devices such as monitors, printers, speakers, and projectors are output devices. Output lets users see, hear, or receive the outcome of what the system just processed. It is often the only visible sign that computing is taking place. You see output in action constantly. A web browser displaying a search result is output. A speaker playing music from a phone is output. A printer producing a document or a smartwatch vibrating with an alert is output. Smart home devices that talk back to you or show settings on a display are performing output. These outputs are the final result of a cycle that started with input and moved through processing. Without output, the user would have no feedback about what the system has done. Storage is the 4th core function, and it plays a vital role in both short-term operations and long-term data retention. Storage allows the system to keep data for future use. This includes everything from documents and programs to configuration settings and logs. Storage can be temporary, such as random access memory, or RAM, or permanent, such as solid-state drives or hard disk drives. Whether the system is remembering something for a second or a decade, it is using storage. There is an important difference between temporary and permanent storage. RAM is volatile, meaning it loses its data when power is lost. It is used for short-term operations and active programs. Permanent storage, like an SSD or HDD, holds data even when the device is turned off. These devices store files, software, and the operating system itself. Both types are essential. RAM allows quick access and faster processing, while long-term drives allow data to be preserved, retrieved, or backed up over time. All four functions: input, processing, output, and storage are connected in a cycle that defines system behavior. A user enters input, the computer processes that input, it produces output, and the data involved may be stored before, during, or after. For example, typing a document on a word processor involves keyboard input, processing by the software, output on the screen, and storage when the file is saved. This cycle applies whether you're creating a document, browsing the internet, or using an app. The IPOS model is not just theoretical, it applies to countless real-world scenarios. When you watch a video online, your device receives input by selecting the video, processes the data to decode the file, outputs the visuals and sound, and may store parts of the video in cache. A global positioning system processes location data, receives input from satellites, shows the route on screen, and stores recent destinations. These common actions are powered by the four essential computing functions. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Understanding the IPOS model is not only helpful for learning, it is a key troubleshooting skill. When a system fails to behave as expected, identifying which part of the cycle has broken down is the first step toward resolving the issue. Is the problem with the input device, like a disconnected mouse? Is it a processing issue, such as a frozen application? Is the output device not functioning, like a dead display? Or is data not being saved properly due to a storage issue? Framing problems this way helps isolate faults quickly and logically. Some devices serve as both input and output tools. A touchscreen receives user input when tapped or swiped and displays output through visuals. Voice assistants like smart speakers take spoken input and respond with audio output. Multifunction printers scan documents as input, print pages as output, and sometimes store data internally. These hybrid devices make it easy to see how the IPOS cycle can overlap. Recognizing these dual roles is important for understanding modern computing hardware and for answering test questions accurately. Processing is often misunderstood because it is invisible. Unlike pressing a key or hearing sound, you do not see the processor at work. However, processing is what makes computing possible. It happens behind every interface, inside every operating system, and during every software operation. When a system fails to respond, it may be because processing has stalled. Software depends on processing to deliver results, and hardware depends on it to execute instructions. Without it, input and output would have no meaning. Storage also tends to occur in the background, even when users are not directly saving files. Many systems use autosave features that store data at regular intervals. Downloads are stored to drive space automatically. Web browsers cache content, storing portions of websites to speed up loading. Even when you're not thinking about it, storage operations are happening constantly. This background activity makes systems more efficient, but also introduces challenges when troubleshooting file paths or managing available space. Mobile devices and Internet of Things systems demonstrate IPOS clearly. A smartwatch receives sensor input from your body, processes it using algorithms, displays output on the screen, and stores your data for future review. A smart home assistant listens to voice commands, processes them using a cloud-based service, responds through a speaker, and stores usage data. Security cameras take in video, process the feed, output it to monitors or apps, and store it locally or remotely. These are everyday systems performing core computing functions. The operating system plays a central role in coordinating all four functions. It manages the flow of data between hardware components, ensures that input is passed to applications, allocates resources for processing, sends output to the appropriate device, and writes data to storage when needed. It also handles driver communication, power management, and error handling. Without the operating system acting as a bridge, users would not be able to interact with systems at all. It is the silent manager behind IPOS. On the ITF Plus exam, you may encounter several question types that test your understanding of IPOS. Some questions may describe a device and ask whether it is used for input, output, processing, or storage. Others may give you a scenario and ask which stage of the cycle is being described. You may also be asked to choose the correct sequence of events in a system task. Practicing this classification and sequence building is an effective way to prepare for these exam formats. There are also several misconceptions about input, output, processing, and storage that are worth addressing. First, input and output are not always obvious. A single tap might trigger multiple internal actions. Second, not all storage is permanent. Temporary memory is just as important as long-term storage in many operations. Third, processing does not always result in something visible. Systems may process data silently for analytics, syncing, or filtering purposes. Recognizing these subtleties helps you answer more advanced or tricky exam questions. Building strong recall around each function improves your ability to apply them in context. Associate real-world examples with each role: keyboards for input, speakers for output, processors for logic, and drives for storage. Practice visualizing a task like writing an email and labeling each part of the process using IPOS. The more you integrate this framework into your thinking, the more naturally you'll apply it across domains. Reviewing IPOS in each subject area reinforces how these core operations underlie all of computing. To summarize, input, processing, output, and storage define how every computing system functions. These four operations happen in sequence, often within milliseconds, and form the blueprint for all digital interactions. From mobile devices to cloud services, from user interfaces to background services, every function fits into the IPOS model. Mastering these ideas supports not only your understanding of systems, but your performance on the exam. These are not just definitions, they are the essential structure behind everything you'll learn in IT. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.